Welcome to Ammonia Offshore, part of the future. You find us here in the Ammonia Energy Association at the last webinar of the year, coming close to Christmas, the end of the week. We hope plenty of you are joining us. We're all exhausted. It's a very busy time of the year. We need you in the audience to pay attention, try and help us along. We need some interesting questions. Catch us out if you can. Today, we are delighted to welcome Philippe Lavagna, Product Account Manager for New Energy's Terminals at IMODCO SBM Offshore. Sebastian Kihle, excuse me if I pronounced that wrong, Sebastian, Chief Technology Officer of H2 Carrier, and Puneet Sharma, Founder and CEO of Cyan H3. This session is recorded, and the recordings will be put up on the Ammonia Energy Association YouTube channel for you to watch, rewatch, pass around, and tell your friends about for the right reasons. Briefly, who is the AEA and who are we, FMA? Never mind so much about FMA. The Ammonia Energy Association is a global non-profit industry association that promotes the responsible use of ammonia in a sustainable energy economy. The AEA's mission encompasses both the decarbonization of ammonia for existing applications, as well as the adoption of low-carbon ammonia in new applications, including direct use as a fuel for electric power generation or maritime transport, and indirect use, as a hydrogen carrier and carbon-free energy commodity. With initial foundation rooted back in 2004, the AEA membership now includes nearly 200 corporations around the world. We, as the Maritime Directorship of the AEA, are working to bring the maritime industry into the low-carbon ammonia fuel opportunity, while also helping to empower the ammonia industry with an offering towards the maritime fuel sector. So these webinars are about maritime insights. This is an offshore one, but it's certainly seaborne. This is the 8th of these that we have done. And we're handpicking select initiatives from around the world to illustrate how solutions are being found to progress the implementation of maritime ammonia fuel. And we want to raise levels of understanding, and we want to connect stakeholders. On the website, you'll find summaries and recordings, as I say, so please go there and catch up on the previous webinars and all the AEA webinars if you like. And look out for announcements for future webinars as 2023 announces. We want to explore topics, particularly around the environment and ammonia of maritime fuel and the evolving regulatory environment, possibly the outcome from the COPs, etc. as well. So we want to get moving quickly. We have 3 speakers and only an hour. We hear offshore energy. We think of oil and gas platforms, wind turbines anchored out in the sea. But we will soon see ammonia production, storage, and export assets joining them out there. Initially, the development of offshore energy industry evolved from the discovery of hydrocarbons under the seabed, and since then, these remote, unpopulated areas with consistent wind resources have also attracted the wind power industry. However, until now, downstream industry has not chosen to co-locate much in this challenging environment. But this is changing. In this webinar, we will hear from 3 companies who pursue an ambition to develop a new industry for low-carbon ammonia production. We have Philippe Lavagna, who I mentioned, will speak about the initiatives of IMODCO SBM Offshore, Sebastian Kihle about the progress at H2 Carrier, excuse me, and Puneet Sharma will tell us about the work being pursued by Cyan H3. We'll hear about, in their presentations, we'll hear them try to answer questions such as who are the companies, what aspect of the new industry are they building, what is their technology and value proposition, and who are their prospective customers. Why place this industry offshore in a difficult environment when you may otherwise choose the usual option of placing it ashore? And most importantly, perhaps, how are they leveraging the vast capabilities available in the existing offshore industry to leap ahead with our plans? So, can we, little on time, great. Can we hand over to you, Philippe, to tell us about IMODCO SBM Offshore?
Yes, thank you, Conor. So I'm Philippe Lavagna. I'm the product account manager for new energy terminals at IMODCO, which is a product line of SBM Offshore. Can you just confirm you see my slides? And then I go.
Yep.
So I'm going to talk about terminals for the transfer of fluid, which has been done for the last 60 years for oil. And basically, the message I'm going to give you is that good news, we can do about the same for ammonia. And of course, we need to qualify it for that new application. But that's basically my key message of today. So first of all, I'd like to thank the Ammonia Energy Association for this opportunity to talk to you. And yes, our drive as SBM Offshore IMODCO is to contribute to a better world by leveraging on our experience, which is about this experience offshore and the transfer of ammonia offshore. So hopefully the next slide will show up. The company SBM Offshore was created 60 years ago with that single buoy moorings that you see on the top right screen. Voilà. And the name SBM stands for single buoy moorings. And today we have the product line IMODCO, which is looking after this historical product, the terminals, which I will be talking about today. Because today SBM Offshore is looking after a very large project, FPSOs, which are worth a few billions dollars, while terminals is not the same order of magnitude of projects. But we belong to this company. We have the same DNA of culture and culture of safety, and that's what we bring to the industry, to this emerging or developing ammonia energy industry. So my pitch is to say there is experience to make use of for what has been done on the oil and gas industry, which will be directly applicable to the transport of ammonia. So back 60 years ago, we used jetties when new harbors were not available or needed to be done. Jetty was thought to be a more cost-effective way, but actually not that much. It was still expensive and poor uptime, which are the two key dimensions to think about: availability of the export or import system and the life cycle cost, which is capex, opex. So the jetty was not too good because it was very expensive to implement and poor uptime when exposed to open sea. Then a more cost-effective way was a fixed heading jetty-less solution. So anchoring the vessel to 4 buoys and with a fixed heading. That was much more cost-efficient, but still poor uptime. And then eventually Shell created this patent of the weather vaning buoy, which is also called a catenary anchor leg mooring. So it's a system that gives two functions. One, the berthing of the vessel, allowing the rotation 360 degrees in a natural way, in a passive way, aligning with the weather. So it's Mother Nature adjusting the heading of the vessel, while we do the transfer, which is the second function, the fluid transfer, which is done within the buoy. So basically, this history over years of experience improved the way to do the transfer of liquid offshore. That liquid was oil, but it can be ammonia today. And basically, that will be good for any hydrogen carrier, actually. Ammonia is probably the main one. And the point is not to reinvent the wheel. There has been already quite good development of efficiency in the industry, which will make use for ammonia. The next slide is about showing a bit more what is a jetty-less system. So basically, if you look at the left picture, you have the storage. Well, here it's for the oil business, but it's the same for ammonia. Your storage on the shore. You have a short pipeline to go offshore far enough to have enough water depth and then the SPM, the single point mooring, the terminal to receive the vessel in open sea, and with this weather vaning capability to adjust in front of the changing weather. As you can see, there are many of those terminals done along the 60 years of experience across the world, and we, IMODCO, have most of those systems delivered. There is a small video which I don't have the time to show today, but I will give my email address at the end, and if you want, I can give you the link so that you can see how it works. It illustrates very well what we're talking about. The next slide, I'll go quick. It's mainly about the technical segmentation, and I save it for the question if we have. This slide is to recap the benefit of having jetty-less systems for ammonia projects. So basically, the context is ammonia will be created in industrial scale and need to be shipped from the place where it's created to the place where it will be used. So that is the key advantage of having a jetty-less terminal. This I keep for the discussion if we have question on CAN buoys and the other type of weather vaning systems, the tower loading unit. And just to conclude, basically, this experience of 60 years is available for ammonia transfer. What we need is to qualify it for the different application, which is the fluid, the contact with ammonia, which has a different chemistry, different temperature. We are talking about liquid ammonia at minus 33 degrees Celsius. So that is the qualification program we have started, and we have already the approval in principle from DNV and ABS, and we'll complete this program next year. That's it for me today, and waiting for your comment and questions later on. Thank you. You can contact me on that email address.
Thank you, Philippe. Bang on time, really impressive. Thank you, really interesting information. I've just put a comment in the chat there. The audience can put their questions in the chat or indeed in the Q&A if they want. So shall we move on quickly to you, Sebastian?
Yeah. Great. So my name is Sebastian Kihle. I'm the CTO here at H2 Carrier. Thank you for the introduction, Conor. We in H2 Carrier have a design for a floating production unit for green ammonia production. As you can see in this picture, it's essentially a floating factory, very heavily inspired by the FPSO technology, which we'll get back to later. Next slide, please. So the technology revolves around using renewable energy that is generally stranded or in hard-to-reach areas or in locations where there is limited capacity in the grid. This means that instead of building a long infrastructure with power lines and transport of energy, you could place the consumption where the energy is available. And this is far off islands, locations with long distance to infrastructure and grid. And the idea is to take this electricity and produce ammonia with it. And to produce ammonia, all you need is seawater, which goes through desalination, and nitrogen, which is from the air. And the product will be liquid, fully refrigerated ammonia, capable of transport to the world with the existing infrastructure that is for ammonia shipping and with exploitable side streams such as oxygen production. Next slide, please. So what I said is the technology is heavily inspired by floating production, storage, and offtake from the oil and gas industry. This was a technology that emerged 50, 60 years ago when they discovered oil assets and gas assets in sites where they were far away from infrastructure, hard to reach, and the volume might not be feasible enough to justify the construction of a full oil platform. So in the beginning, they took existing very large crude oil carriers and they took them to a shipyard, did a life extension, reinforced it, and then put a chemical oil refinery on the top side of the vessel. That way you could take an existing asset, refurbish it, put a chemical production facility on top, and then move it out to the site where the oil is. And that way you could more rapidly and cheaper deploy and refine the oil that would otherwise be considered a stranded asset. And this is the same thing we wish to do using green ammonia as the medium instead of oil and gas. So it's our design is initially based on taking a very large gas carrier, a VLGC that has ammonia compliance, and then taking it to shipyard, refurbishing it, doing a life extension and putting a chemical plant on top for ammonia production instead of oil and gas production. And we see that this technology is very mature and sort of off-the-shelf technology generally. Next slide, please. So here's an overview of the components that are on board. Ammonia production is relatively simple compared to some oil and gas extractions. The chemical process of producing ammonia is always the same, but for a FPSO in the oil and gas industry, the concentrations of oil and gas is always different, so you need a more tailor-made design. Our design is a lot more general because if you can get electricity at the right volume and at the right frequency, you can scale the vessel up and down relatively easily. So on board you have the power reception unit to distribute power to all the components. You have pumps that pump on board seawater that goes through desalination, demineralization, electrolyzers for producing hydrogen, nitrogen extraction, which extracts nitrogen from the air, which is combined through the Haber-Bosch process to produce ammonia, which is cooled down and stored in liquid state in the tanks of the vessel. This is the chemical production aspect of ammonia. Has been around for a very long time. It was originally, I've seen drawings of ammonia plants running on electrolysis from all the way from 1925. So it's essentially a 100-year-old technology. And the electrolysis has since a large-scale production since the 1940s. Next slide, please. You might want to ask, what's the purpose of building this on a ship instead of just building it on land like everybody else does? There are a couple of good reasons for this. We will have our construction at a shipyard or at a large workshop. This centralizes the construction with all the personnel, tools, and equipment in one central space that decreases the need for logistics and transport of both personnel and material. There's significant public and regulatory advantages, such that you do not actually require any land, almost. So the concession for production is easier to achieve. It is a mobile asset, so even though we wish to remain on site for the lifespan of the vessel, if the underlying circumstances drastically change, you could potentially relocate it, so it will never be a stranded asset. It's also based on the converting of an existing vessel, which is an upcycling using a VLGC ship for something more environmentally friendly than it was originally designed for. And at the end of the lifespan, you can easily recycle it as it's mainly steel, and steel is relatively easy to recycle. Next slide, please. So what we do here at H2 Carry is practically the entire Power-to-X value chain. We identify renewable energy, work together with renewable energy developers, establish off-take agreements on the ammonia, then we do the engineering, procurement, contracting and installation, construction and installation, with all the planning and the design of the vessel on top side. And then we do the operation and maintenance and can contribute to the distribution of the ammonia. And that way you have a full value chain that easily can enable the development of stranded renewable assets and bring them to the market through ammonia without expensive and time-consuming infrastructure such as extensive power lines and with minimal need for the use of land. I think that was the last slide. Thank you.
Okay, you're also on time. Amazing. Thank you. That's fascinating. And again, let's just keep the momentum here. Do you want to kick off there, Puneet?
Sure, Andrea. I worked for IMODCO for about 20 years in the FPSO space. I worked on about 45 different FPSO projects in my life. The last 10 years was spent as a VP of project development. So I've got experience with FPSOs on almost every continent on the planet other than Antarctica. I left IMODCO in 2019 and joined Pelican Engineering as a consultant. In 2021, 2 Japanese trading houses asked us to consult on first green ammonia FPSO concepts, and then later in the year on a green hydrogen FPSO concept. When we first did the consultation on the green ammonia FPSO concept, we did a techno-commercial analysis and concluded that it was not commercially viable in the current climate. With the green hydrogen FPSO concept, we created a full techno-commercial analysis using an offshore oil and gas simulation model called OGM. The trading house is continuing the work on the green hydrogen FPSO concept, and they've put a hold on the green ammonia for the time being as they're looking for funding to achieve that. Next slide, please. So what we did was, after we realized that the green ammonia FPSO is not commercially viable at the moment, we realized that there is an opportunity to create a blue ammonia FPSO, which would be commercially viable. So we did a conversion concept using and developed a blue ammonia FPSO solution. And based upon the experience of the shipyards and the various contractors we've worked with, we calculated that if we had a minimum of 1,500 tons of ammonia production in the form of blue ammonia on a FPSO, that it was commercially viable. Anything higher than 1,500 tons per day is definitely commercially viable. During that process, we talked a lot to a number of companies, including the AEA, and we also learned about this whole idea of green hydrogen as a storage medium for kinetic energy, offshore kinetic energy. The problem we saw when we were doing the analysis earlier is that hydrogen in itself is difficult to store, while ammonia is much easier to store and transport. As IMODCO points out, the ammonia and LPG behave very, very similarly. The transport systems that have been available for LPG can also be used for ammonia. So using that basic set of knowledge and technologies, we developed that blue ammonia could work. So it's fine to come up with a technical solution, but then you have to decide whether that thing can actually make money in the market. Doing a bunch of research, we realized that there's 3.2 trillion cubic feet of natural gas being flared every year. That is equal to 263,000 tons of greenhouse gas carbon credits per day, and up to 265,000 tons of ammonia production per day, which has a value of $159 million per day. So definitely we concluded that a blue ammonia FPSO would work and could be sold in the market. So in early 2022, we created CyanH3 to develop and promote the monetization of flared and stranded gas to ammonia, as well as that same solution being able to morph into a green hydrogen ammonia production solution in the future. Next slide, please. The reason why we call it cyan instead of calling it blue ammonia or green ammonia, created the concept of cyan ammonia, is when you look at green ammonia production and blue ammonia production, all the boxes that are colored in cyan are either same or similar between the two processes. In green hydrogen production, you're using green energy and an electrolyzer to make hydrogen. In blue, you're using natural gas and steam reforming to make hydrogen. The one other step that's different between the two processes is in blue ammonia, you have to separate the CO2 out, whereas in green ammonia, you don't. So if you think about the overall asset, the hull is the same, the living quarters are the same, the mooring system is the same, minus maybe some modifications in electrical swivels for power incoming or hydrogen outgoing. Almost everything else is the same. As a process engineer, when I looked at the overall top sides, 80% of the top sides between a blue and a green hydrogen ammonia solution is identical. Next slide. One thing that I did when I was at MODEC is we looked at FLNG starting in 2015 And we looked at various hull forms. We looked at about 13 different hull forms for conversion into an FLNG unit. And our end conclusion was that the existing hull forms are not ideally suited for conversion into a storage unit that can store liquefied gas. So we developed our own FLNG hull using different storage mediums. That FLNG hull included storage for LPG, condensate, and LNG. So using that knowledge, we looked at the idea of an ammonia FPSO and concluded that similar to the FLNG problem, existing hull forms are not suitable for conversion, easy conversion into an ammonia FPSO. There is one hull form that we've concluded will work. Those are, and I don't want to discuss that here, but there is one possible solution using a conversion. Outside of that, in order to satisfy various parameters, we've concluded that a new hull form is required for ammonia storage. The functional specification for this hull form is shown on the table on the top on the right, and a pictorial diagram of what it might look like midship is shown on the left. It's very, very similar to an FPSO. It's not identical to an FPSO hull form, as it accounts for the type of storage that's going to be required for ammonia, as well as other storage required in the hull. Next slide, please. The layouts for the green and the blue ammonia are shown here. The capacities are shown, sorry. There's a comparison table showing capacities on the top right for floating ammonia versus floating LNG. One of the beauties of floating ammonia versus floating LNG is in FLNG, you're going to take natural gas, you're going to process it, send the LNG to shore. The consumer on shore is going to consume that LNG, produce CO2, and is going to end up with carbon tax. In floating ammonia, you take the natural gas, produce the ammonia and or hydrogen, send the hydrogen to shore via pipeline, send the ammonia to shore via tankers, and you take the produced CO2 from your FPSO and re-inject it back downhole. So you have 100% carbon sequestration potential for with floating ammonia versus zero potential sequestration with FLNG. Next slide. Current status, we approached VC funds in 2022, and we're told that they weren't interested unless we did a number of things. First thing is they wanted us to have a patent. So we worked throughout the summer of 2022 and filed a patent in September of 2022. They also told us we had to develop a study, a feasibility study. We've proceeded with the feasibility study. We've iterated on the hull at least 3 different times now. We expect this hull iteration to take us about 9 to 10 months. We've applied for grant funding to do a full-blown feed on the solution. In the meantime, we're going to continue to iterate on the hull. And we've also got a partner company that's working on a pilot plant, 50 ton per day onshore pilot plant, to prove all the technologies that we intend to implement on the FPSO itself. That pilot plant should go online by March of 2023. I think that's the last slide, Conor.
Thank you. And we are still relatively well within our boundaries. I can see that Puneet and Sebastian could have a good argument if we wanted to see that, about a few points there. That's to be expected. We are in a nascent kind of situation with this concept, with these concepts offshore, and I think that time will probably prove both of them slightly wrong in some ways. Maybe And the good thing is that we have all these different ideas popping off and things happening, and it's moving forward. And the overall message here today is this is part of the future in whatever form it ends up being. So rather than try and encourage you two to have a fight, which I think I'd just like to ask you some kind of boundary questions, perhaps, just to establish a few facts. We have on this call, as we were talking about when we were waiting to come on, we have me in Sweden, Philippe in France, Sebastian in Norway, Puneet in the US, and Andrea backing us up in Mexico. So Sebastian, what regions do you see your technology being employed?
That's a good question. We see that, you know, the coming demand for power in all forms is significantly going to increase, especially in Europe, where it's up until recently been mainly, or a lot has been powered by gas, natural gas. So we see that in order to meet the demands of the coming future, you need to get energy from all sources. And we see that a lot of the sources with the best conditions for renewable energy, they are generally in conditions that are hard to reach, such as islands or windy places far away from cities and infrastructure. And the challenging part of those places is to get the energy. It's not to produce the energy, but it's to transport the energy. And we see that if you can establish consumption where the production is abundant, then you can bring energy to the market via the transport of ammonia relatively easily compared to building X amount of kilometers of power lines. So we're focused on sites with the good renewable energy conditions that necessarily don't have any good conditions for export as of today, or sites that have surplus energy in the grid, but not the capacity to transport it. We have a project on that too. And, you know, it can also be contributed to energy storage in form of ammonia production that could potentially be used to produce power again using a gas turbine or crack it back to hydrogen and hydrogen fuel cells. There are many solutions to this. So it's also a way to store energy over longer periods of time on a seasonal scale and not just hour and days like electrical batteries.
So and when you're looking at this, so you're thinking like maybe primarily about isolated renewable energy. And when you're looking at this, you know, unless you're going to store it and generate electricity, you're going to have to offload it, and this is transferring fluids at sea, and this is very much Philippe's business. But what competencies have you guys seen when you, obviously, when you're going out with this idea to the uninitiated, to people who don't know about it? One of the first questions they're going to come up with is, well, how do you get it off the darn thing onto a ship to move it somewhere?
That's a good question. We have the sort of generally two versions of our vessel. And we have the near shore version, which is for a more sheltered location with a less challenging environment in terms of waves and wind. And we see that if you have a sheltered location where you can place the production unit, you could do side-by-side ship-to-ship transfer. And the hose technology for ship-to-ship transfer of ammonia is already there in at some level, because ammonia has very much the same qualities as liquid petroleum gas, LPG. So transfer has been done with LPG for a long time. The only difference between ammonia transport or transfer compared to LPG transfer is that you have to have a hose that has the right corrosive resistance that ammonia to compensate for the corrosiveness of ammonia, and that hose technology is also available. So it's just a matter of putting two existing components together in a new configuration. But I think Philippe has a lot more experience in this than I do.
Yeah, I think that, yeah, because I was going to say to Philippe exactly. So, I mean, mainly ammonia as a cargo these days is traded by sea as a commodity, is transferred at the jetty, and very rarely it's transferred kind of ship to ship offshore. And, you know, what do you think is the progress now between the situation we have now and getting to where the oil industry is using buoys?
Yeah, so indeed, the key element of the puzzle are the bonded hose. I mean, the flexible fluid transfer. And there are at least two companies, to name them, Trelleborg and Dunlop, who are developing ammonia hoses. So indeed, we are not starting from scratch, because it's from a temperature viewpoint, it's very close to LPG. It's more or less the same temperature. It's not the same chemical, so that's what is part of the qualification program. And basically, this work will be completed as per those two companies by end of next year.
Are you talking about floating hoses?
Floating and submarine hoses, because it's the same hoses at the end.
Mm-hmm.
What we are qualifying ourselves is the swivel to give the weather vaning function. As you know, we are experts in this technology, and this is a very important piece of the puzzle. And then as well for the buoy, at the end of the pipeline, before the submarine configuration, that there is what we call the PLEM, the pipeline end manifold, on which there is a safety critical element, the emergency shutdown valve, that basically shut down the pipeline inventory from leaking in case there is a major issue with the subsea configuration. And that needs as well to be qualified for minus 33 degrees Celsius operation with ammonia. And we are also working on that.
And is the PLEM on the seabed then?
PLEM on the seabed, yeah. I have a slide to show if you want, but I don't know if we have
some of the names, like a cam buoy, which is a very well-known term in the industry, a cam buoy, which is a buoy which the ship comes up to, ties up to, takes a hose and loads. Doesn't have to go into a port, doesn't have to go to a jetty. It's a great concept. But catenary anchor leg mooring, I mean, it's really this is some of that. And then PLEMs and cam buoys and catenaries. Catenary is the curvature of a rope or a cable between 2 points. Okay, so we have a slide here.
Yeah, so basically, oops, let me go back to that slide here. Do you see the cam buoy slide?
Yeah.
So indeed, the catenary is about the mooring lines, which are typically made of chain, and that's what gives the restoring, so to keep the vessel in position. That's what we call the position clipping. And that is the same thing that what we do for the last 60 years. It's the marine part of the job, which is more than well known. It's very regulated by OCMF, etc. So we have all the experience. What is kind of new is the application with liquid ammonia. But the rest, yeah. How we design the thing and so on, is something we are experts, and we know exactly what we have to test. Because of course, what we have not mentioned, but it's a bit in the discussion, is the toxicity of ammonia, and we have to treat it very carefully to make sure we don't have a leak. And that's the reason why we believe we have something to bring to this emerging industry of large-scale ammonia industry, is the safety element, to make sure that we do it in the wise way, making sure every corner is well checked.
Yeah.
So that's what we are developing.
You mentioned an acronym there, OCIMF, and that may not be known to all listeners. That's the Oil Companies International Maritime Forum, which is a very strong force for governing the safety and regulation of the oil industry. And
exactly,
it's interesting that to mention that in an ammonia context, but we're not going to get deeply into regulation today, but it is very interesting. So that's what OCIMF is. When do you see, like looking ahead now to what the work you have ahead of you to get this approved, when do you think you'll have your ammonia system qualified, as you say?
Next year.
Okay.
And by end of next year, we'll be done with the qualification of all the components. What we have achieved this year is approval in principle. So we have ABS and DNV who have basically reviewed our work and all the elements that we need to qualify, because there are elements to be qualified. We cannot just go offshore. We have to make sure it works as we think it will work. But they basically have approved our qualification plan by giving us the approval in principle. And now to be fully qualified and to commit our company on the system that will work, we need to finish those testing that are planned and will be completed by end of next year. So there are testing that we do ourselves and testing that we follow with suppliers.
Okay. So that's great because it kind of lines up with a lot of other developments which are expected to fall in over the next few years, not least maritime engine development, for example.
Yeah, the value we bring is that we will put our stamp on it, saying, okay, the overall system is good to use.
Yeah. Look, just a quick side question here, very quickly. And have you thought about this not only for kind of offloading in the offshore environment? It could also be used by ammonia tankers that are carrying ammonia as a cargo. I mean, from traditional coastal ammonia plants.
Mm-hmm. Yes. So basically, everything we have done with in the oil industry will be applicable. Vessel coming close to the shore in a sheltered area, or offshore from an offshore producing terminal, like Sebastian was talking about. Everything will be again available using those same pieces of the puzzle, which we are qualifying today.
Yeah, excellent. Turning to you, Puneet, you touched on it, I think, during your presentation. Floating LNG is becoming more popular. There's a lot of big floating LNG projects out there, and you could potentially harvest some of this flare gas, for instance, and purify it and store it for floating LNG, or whatever way you look at it. Why have you gone more into the ammonia side?
Right. So floating LNG has been around for a long time. When I was at my former employer, we bid on and were awarded an FLNG project back in 2009. The fundamental problem with FLNG is the offloading system itself. The loading arms cannot operate in wave conditions higher than 1.5 meter significant wave height. The hoses cannot operate in anything higher than 5 meter significant wave height. When you look at the world where these FPSOs, the new FPSOs are going, they're all going into not very harsh environments, but semi-harsh environments, meaning that in Brazil, for example, in the pre-salt region, significant wave height is 8.5 meters. Gulf of Mexico, it's 11 meters. Off of Australia, it's 11 meters. So in these particular environments, the FLNG solution will not work until FMC and Technique come up with another solution. They are working on hoses that might work in 10 meter significant wave height, but they're still far off from that. So when you look at this world of stranded gas, and there is tens or hundreds of trillions of natural gas that are stranded around the world because there is no way to send that gas to market. The project in Angola is 500 nautical miles to the nearest LNG plant. The Namibia gas is 1,000 miles to the nearest LNG plant. The Guyana developments with Exxon, that's another 400 miles from the nearest LNG plant. So, and in Guyana, an FLNG solution will not work. The floating ammonia solution, because it's a simple, I call it a simple, and Philippe will probably get mad at me for this, but with Trelleborg working on the hose solution and the long experience that we've had with LPG tandem offloading from FSOs and FPSOs, the floating ammonia FPSO with tandem offloading should be a natural solution for that stranded gas.
So it's because the properties of the gas make ammonia easier to offload in a difficult environment.
Correct. And when you look at this, you also, if you factor in also this carbon credit business that started up, when you send LNG to shore, if you put it on an FLNG unit, let's say you produce LNG on an FLNG unit, your thermal efficiency is between 70 and 85%. And you have up to a 10% loss in LNG during the transport of the LNG to So you're
just leakage.
Yeah, boil off
of a potent greenhouse gas. Okay.
Well, it's boil off that gets recycled back into the tanks.
Okay, that's different then, yeah.
But that boil off sometimes is then used as fuel itself.
Yeah.
Right. If you're traveling, go ahead. If you're
I generally agree with the fact that indeed FLNG is not going to happen too often compared to floating ammonia. I think the main parameters is about economics because the offshore fluid transfer, we could do it, we have the technology, but the overall economics are no longer not too much in favor of floating LNG. I mean, there are still cases with the floating LNG, and we see in Mozambique and so on. But indeed, on ammonia, as well put by Puneet, there is a double kiss school effect, which is one, the carbon tax, and two, ammonia is wanted for many use. So there is a high value of ammonia. So it's mainly the economics that will drive the show.
Conor, there is a backup slide that I have in the presentation slides that may be useful also in explaining what my colleague just mentioned. If you go to the backup slides, Andrea. So if you look at this slide, at the bottom left is a graphic that depicts the price of natural gas in various markets and the simultaneous price of ammonia in similar markets. When US Gulf Coast Henry Hub price hit $8 a million BTU, the price of ammonia hit $1,200 a ton. When you translate the gas to ammonia, the equivalent, $1,200 a ton is equal to saying $36 a million BTU. So if I was to take, let's say, gas at $8 a million BTU, convert it to LNG and sell it as LNG, at most I might get $16 a million BTU. If I convert that gas to ammonia, my value is now $36 a million BTU. So if I can take the blue ammonia FPSO, put it on my stranded gas, I've just made a gold mine.
Is that kind of like refining ore and selling gold instead of gold ore?
Yeah, and doing it offshore.
Okay.
And as Philippe said, you know, ammonia is not just, I mean, we're talking about ammonia as a maritime fuel, but ammonia is already being used as a fertilizer. And the war between Russia and the Ukraine has eliminated roughly 10% of the global ammonia supply. And in 2023, when Yara and BASF shut down these ammonia plants, that's going to eliminate another 13% of the global ammonia supply.
It's fascinating. And you're looking at maybe next year for having your kind of basic design finished, Puneet, is that right?
We're proceeding with the design based on our own finances, but these types of designs require a lot of money. So we have applied for grant funding to try to progress the design, but the intent is to have it done by the end of next year.
Okay. I'm going to switch to the questions that are coming in through the Q&A because the poor audience, I'm sure, have loads of things they want to ask, and we don't have much time left. So some practical questions. Jennifer's asking, for ammonia production on a platform the size of a ship, what tons per day are desired, and is that based on nameplate capacity or renewable resource availability? So this is quite a specific question. Does anybody want to take that? Production and kind of nameplate or resource wise?
I can take it. So for a ammonia production platform, I would say it depends on the site for the most part. We have sort of two, as I mentioned earlier, two versions of our design. It's the nearshore version and the offshore version. For a nearshore version, you're less exposed to waves and such, so building a larger scale is easier, and it's usually more economically feasible because, you know, the scale of when you increase the scale, the cost goes down. And at the offshore version, it's a little bit more challenging because you can't have a simplified hull design. You have to have a proper offshore hull design. But we've been looking at, for example, in an offshore environment, a 200 megawatt production unit has a production of about 440 tons per day. of ammonia, and but that's a relatively small production unit. 200 megawatts is a relatively small scale ammonia production unit. Well, for near-shore operations, we're looking at scales up to 1 gigawatt, and that, of course, is quite the vessel in size. 300 or 270 meters and 50, 60 meters wide. It's quite the unit, and that the limit there is usually actually the size of the yards in the world.
Yeah. Okay, so Jennifer, we're not getting the kind of your side of the question with the nameplate or the renewable resource, but maybe you can reach out to Sebastian and explore it more. It's kind of quite a technical question.
Conor, was that question strictly for green, or was that also for blue?
It didn't say, actually, but again, is it okay if we ask you, Jennifer, to kind of catch up with Puneet and Sebastian bilaterally and take that, just so I can try and cover a few more questions before, but I'm sure she's interested in any color, any type of, any pathway. Safety. So Sahib is asking, in a congested space, there's always concern with H2, but particularly in a congested space. And I know at least probably all of you have dealt with this, how to deal with this in a congested space. Does anyone want to talk about what work you've done on this fact? You can't spread your factory out over a big space. You can't spread your plant out. You've got to condense it all. Sebastian, again.
Yeah, this was, of course, one of the main concerns when we went through our approval in principle with DNV. We went through a hazard identification called HAZID, and here we laid out our design for how to store the hydrogen for our buffer tanks in the production. And we see that placing the hydrogen storage tanks on the top of the vessel is the safest way to handle it, because it maximizes the distance to any potential other compartments and storage of other gas or liquids. So a serial explosion is very unlikely to happen. We can also have blast walls beneath the tanks. Also, if there's a hydrogen leak, since hydrogen is extremely light, it will fly upwards. So if there's a leak and the tanks are at the top of the vessel, the exposure and the explosion risk has been minimized all the way as possible.
That's a good comprehensive roundup. I think there is a lot of questions, general questions about financial impact, carbon footprint of production, and I guess the intention here is to reduce the carbon footprint as much as possible. Risk of ammonia spill in the ocean. Yes, this was given by an anonymous attendee, but absolutely. Would anyone like to speak to risk of ammonia spill? Maybe Philippe, you could.
Yeah, so it's not the first time we are managing, the industry at large is dealing with transfer of ammonia. There are already a few vessels transferring a cargo made of ammonia. What is new is to do it offshore in open sea, and indeed large quantities. We are talking about potentially much larger quantities than before, larger offshore rate and so on. So eventually the leak could be larger. So in the air, we have the data. We know that it can create clouds that are very toxic for human and can kill people. So that we manage, and we make sure we do not expose people to potential leaks. The first thing is to avoid the leaks. And subsea, that is something we are looking at. We had that discussion just before the webinar, Conor, on what is the real impact on the mine life, whether it's the same if it's in open sea or whether it's close to the coastal and so on. So that is being developed. But for sure, by now, we are taking the conservative approach that it will be very severe. So we make sure that we have a heavy safety margin and a very strict safety approach on everything we do to design the system to make it very safe. That's what we want to take to the industry.
Yeah, I think, there's a long history in the industry of preventing hydrocarbons getting into the sea, and all the same techniques will be applied. There's a Charles, I think, Lulier asking two questions. And it's again on the environment, actually, Sebastian. I see you're using desalinated water. How do you intend to deal with brine and other environmentally harmful substance residues?
That's a good question. And of course, taking care of all the environmental impact and footprint is at the core of our design. So it's one of the reasons we're a floating asset and not the land-based, to minimize the use of land. We will have storage tanks in our vessel for residual liquids such as brine and other chemicals that might be used to maintain a no growth of any kind of organisms within the coolant water, and then you need a purpose tank for that. And one of the things that separates an ammonia floating production unit from one that's conventionally used in oil and gas is that for an oil and gas FPSO, the volume of the tank storage is essential to be able to deal with all the production, because it has a very high production, because you're not actually producing the product, you're just pumping it from the seabed. But for ammonia, the tank storage does not need to be as big, which leaves a lot of room under deck for other kinds of tanks, such as tanks for chemical potential dangerous chemicals.
Okay. And Charles is also asking about techno-economic challenges and picking up on a potential kind of different perspective within this group. And I think, Charlie, if you can reach out to us, either you can reach out, if anybody wants to reach out to us, I'll put our address in the chat, and we can try and route your questions to people after the webinar, because we're just going to run out of time. We have 4 minutes left. There's another question about environmental impact, CO2 sequestration, many great questions. And I'm really sorry to those of you in the audience that haven't had them answered directly here. I think that they are great. I'm going to put our email address here in the chat now. So we are fma at ammonia energy.org, not .com. You can hit us there with questions, and if you want to connect with the panelists afterwards. We'll finish with a final question, and there is a question about regulation. Regulation. The root of everything in some ways. So here's your final question, guys. Given that we are comfortable with being able to break through technological, safety, environmental, and commercial barriers, with your organization part of an established offshore low-carbon ammonia value chain by 2030, which is only 8 or 7 years away, what relevant offshore regulations have been changed or put in place to enable your progress? Puneet, do you want to start that one? I think you might be muted. Actually, try again. Okay, not sure, but you seem to be muted.
Do you want me to do the offloading part then?
Yeah, go ahead, Philippe, and maybe
okay.
Puneet, you can.
So for the part of cargo transfer, we are basically kind of two industries and regulations. So OCMF, we already mentioned it, that's about oil transfer at sea, which is very well regulated. So we are going to make use of it because that's basically about the marine operation. And there is SECTO, who is managing everything about the gas carrier. So basically, and gas carrier up to now, we are usually going to ports, so or jetties. So what we are going to merge is the two, and that's the novelty, and that's where we make sure we make it in a safe way to create that a new set of standards for gas carrier in open sea. But basically, it's merging two existing set of regulations.
So you're going to focus on. So you said OCIMF and SIG2.
SIG2 is focused on gas carriers.
Yeah. And
gas carrier up to now they are going to ports or to jetties. And now what we are going to do is the weather warning systems for gas carriers.
Okay.
So that's what we have to manage, and that's where we can bring value to the industry because we have the experience with both, and eventually we need we need to see whether we need to make a new regulation or not, but at least to make sure there is no gaps between the two.
Okay. Thanks, Philippe. Puneet, do you want to try again?
I don't know. Can you hear me?
Yeah, perfect.
Sorry, my Bluetooth headset popped off. As Philippe said, this is an evolving situation. There is a lot of work going on in Europe, particularly on ammonia. But the United States, for example, is years behind on addressing the issues. The very first groups, I think, that are going to be focused are going to be Europe, and now the Middle East seems to be taking hold of the idea of blue ammonia. And that's where I think you're going to see more work.
Okay. Can we move on to you, Sebastian? We're actually on the hour, so we've got to go.
Yeah, I don't think the regulation is already there for the most part for our sake, but we want to connect to offshore renewable energy, and I think the regulation there is a bit more difficult because every country have their own sort of set of rules, and some concessions are always have the power connection built into the concession, so it's hard to establish a project without power cable to land, even though that is possible if you have a floating production unit on the site. So
that's interesting for regulators and policymakers. Yeah, it's a barrier. Yeah. I think we have to stop there. We're already over time, and we try to be on time. Thank you all so much. It's been fascinating and a great end to the week. I hope the audience, I'm sure the audience have smoke coming out of their ears. There's been so much information going on here. Really appreciate it. Thank you so much, and best wishes to everyone for the holidays coming up. And don't be afraid to tune in again. Next time we'll be putting out announcements for our next webinars. Have a great weekend.
Thank you.
Thank you, likewise.